Next, we have a problem here, JEE Advanced 2021, Paper 1. This was a range problem in probability. We can use set theory here to simplify. So it's a very good problem we'll discuss here. So probability of three events, P of E is 1 by 8, P of F is 1 by 6, P of G is 1 by 4, and P of E intersection F intersection G is 1 by 10. Whenever we have range problems in probability, the best way to do is we assume total number of elements. How do we assume total number of elements? Just take the LCM of the denominators. 8, 6, 4 and 10. The LCM will be 120. So total elements will be 120. If total elements are 120, from their probability we can find the number of elements in E, F, G and E intersection F intersection G. So n of E will be 15, n of F is 20, n of G is 30, n of E intersection F intersection G is 12. Now, how do we proceed after that? So we just make a number line. We have say 1 to 120, 120 elements, and E has 15 of them. So let us just say first 15 elements are with E. E intersection F intersection G is 12. So let us say 1 to 12 are common in E, F and G. Now, how do you find range now? So the first one they're asking probability of E intersection F intersection G complement. So we'll try to figure out what is the maximum number of elements in E intersection F intersection G naught. What is the meaning of this? This means the number of elements which are present in E and F but not in G. Present in E and F but not in G. So you see E has total 15 elements, out of which 12 are already common with E, F and G. So these elements we cannot take because we have G here. So the remaining elements of E are 3 only. F has 20 elements, 12 already gone here. So F has remaining 8 elements. That means those 3 elements of E can be common with F. And we cannot have more elements because 3 only has 3 elements left. So maximum number of elements which could be present in E and F without G is 3 only. And total elements are 120, so maximum probability will be 3 over 120, that will be 1 by 40. So option A will be correct. Next, second one. This thing E naught intersection F intersection G. So E complement intersection F intersection G. That means those elements which are not present in E but present in F and G. Again, with these 12 elements we cannot take. So if we leave these 12 elements, F is left with 8 elements, G is left with 18 elements. That means they can have at max 8 elements common. So for example, like 15 to 23, these 8 elements will put common in F and G and they will be without E. But at max we can have 8 only because F is left with 8 elements. So we cannot have more than that. So maximum value of this is 8. So probability will be 8 over 120, which will be 1 by 15. So option B will also be correct. Next, I think maximum probability of E union F union G. Now, to find the maximum number of elements in E union F union G, you can see this formula: n of E plus n of F plus n of G minus n of E intersection F minus n of F intersection G minus n of G intersection E plus n of E intersection F intersection G. You will see that n of E, n of F, n of G are already fixed. This thing is already fixed. If you see n of E intersection F, see in E and F, these 12 elements are already in common. To make n of E union F union G to be maximum, we'll try to keep this thing minimum. And this will be minimum if E intersection F has only these 12 elements common. So nothing else should be common in that. That means the remaining elements of E and F should not be common to each other. So what we will do is we'll take all the elements of E from 1 to 15. Then the next 8 elements of F we'll take after that. 15 to 23. We'll give it to F. Similarly, the G elements. 12 already common here. Next, whatever will be there, we'll take it outside only. So 12 already common, we need 18 more elements. So we'll take next 18 elements, that'll be up to 41. That'll be for G. So that'll be the maximum value of E union F union G, 41. See again, we take 1 to 15 for E, then next 8 elements for F, then next 18 elements for G. So that they have nothing else common apart from these 12 elements. If they have nothing else common, then this thing will be minimum and this will be maximum. So you get 41. Now, if you take 41, probability will be 41 by 120. They haven't given the exact same thing. So we get maximum value to be 41 by 120. They're asking 13 by 24. If I multiply with 5, we get 65 by 120. So you can see that whatever value we have got, it is less than this only. So option C also will be correct then. And the last part, E intersection E naught intersection F naught intersection G naught. We have to find its maximum value. Again, we do the same thing. We see N of E naught intersection F naught intersection G naught is total N of U minus N of A union B union C. So you can say this will be maximum when this is minimum. And E union F union G. I'll just change EFC here. So this is supposed to be E union F union G. Now this thing will be minimum when this will be maximum. That means the number of elements in E and F should be common, should be at max. F and G should be at max. G and A should be at max. So whatever elements are remaining apart from these 12, those also will take common pairwise. So E has 15 elements. First 12 already common. Next 3 I'll take common, let us say with E and F. So the remaining 3 elements here will go to F also. So 1 to 15. E also, F also. So now E is finished here. Now F has 5 more elements. Let us say this 15 to 20 is for F. And G also will take common with that. So this will give to F and G. So now G already have used 12 elements. 5 it used here. So 17 are used. That means 13 more elements we have to give to G. So that will be total 33 elements. So they will cover 33 elements. So that is a minimum value of N of E union F union G. So if this minimum is 33, that means the maximum value of this thing will be 120 minus 33, which will be 87. And with 87, when you find the probability, it will be 187 by 120. If you see here, they have been 5 by 12. If I just divide by 10, you get 8.7 by 12. So our maximum value is 8.7 by 12. They have given 5 by 12. That means this is wrong. We can have more than this. Correct answer will be A, B, C, but not D.